Good morning, students. This is chapter number 10, Wave Optics. And today's topic is interference and diffraction of light. It means we are going to distinguish the interference and diffraction of light, right? So, student, you know that the interference is the phenomena in which we get maxima and minima, means constructive and destructive interference, right? So in interference there are two sources. These sources are monochromatic sources. Let these two sources are S1 and S2. Both are monochromatic and both emitting the light of the same wavelength as well as the same frequency, and the phase difference between these two wavelets is constant with time, right? So after superposition we get maxima or minima due to superposition. So in a young double slit experiment there were the two slits which were illuminated by the single source, right? This was the primary source. Then what happened? In the first slit there is a wavefront, and at the second slit there was second wavefront. Now the particle of the primary wavefront act as the secondary source. Since the width of the slit is very small, means these slits are very narrow, so only one particle of each wavefront exposed and start emitting the wavelets, right? Similarly, from the slit number 2, a single particle of this wavefront also becomes the source and start emitting the wavelets. After superimposition or superposition of these two wavelets or these wavelets, we get alternate maxima and minima on the screen. So this is the interference pattern. In diffraction pattern, there was only one slit, right? And there was a source. But the width of the slit in diffraction pattern is larger than the width of the slit in interference. Means when wavefront get incident at this slit, so more than one particle becomes the source for the secondary wavelet. After emitting the wavelets from these secondary source, we get the superposition of these wavelets, and on the screen we also get the maxima and minima, means bright fringes and dark fringes. But the diffraction pattern is quite different from the interference pattern. Now we are going to distinguish the diffraction and interference. So this is the difference between interference and diffraction. Now see the intensity graph of interference. The first one is interference and the second graph or intensity variation of diffraction pattern. Now see the difference. In interference, the width of all fringes is similar. All the maxima and all the minima having the same width, and that is equal to d lambda by d, right? This capital D means distance between the slit plane and the screen, means slit plane and screen are separated by a distance capital D, and small d is the distance between two slits, right? So this is the fringe width of each fringe of the interference pattern. But observe here, the width of the central maxima is double as compared to the secondary maxima. Second one, all secondary maxima have same width except center one. The central maxima has double width. Right? Now see the intensity. In interference pattern, all maxima have same intensity. Means these peaks are at same height on intensity axis. Right? But in the case of diffraction, the intensity of central maxima is highest, whereas the intensity of secondary maxima goes on decreasing with order. Means the intensity of central maxima is highest, then intensity of first secondary maxima, then intensity of second secondary maxima, then the intensity of third secondary maxima, and so on. After some space, the diffraction pattern disappears. So there is a good contrast between maxima and minima, and there is a poor contrast between maxima and minima. Since in the higher order the intensity becomes very small, means we cannot distinguish the separation between dark and bright fringes in diffraction pattern. So these are the basic differences between interference and diffraction. Now we are summarizing these factors. Interference is due to superposition of two different wave trains coming from coherent sources. Right? Since there are two sources, coherent sources means the sources having same frequency and wavelength and constant phase difference with time. In diffraction, due to superposition of secondary wavelets from the different part of the same wavefront, right? It means the particles of same wavefront acting as the source, and due to superposition of these wavelets, we are getting the diffraction pattern, right? Next point, fringe width is generally constant. In all fringes, whether it is maxima or minima in interference pattern having the same width, and that width is d lambda by small d. Now in diffraction pattern, fringes are varying width. The fringes having varying width means the central maxima has twice as the width of other secondary maxima. Right? Next, in interference, all maxima have same intensity. All the maxima having same intensity, whether it is first maxima or second maxima or central maxima. Okay? All having same intensity. Now see the height of these peaks. It means intensity is similar for the interference pattern. Whereas in diffraction pattern, the maxima are varying intensity, are of varying intensity. Now see this graph, the intensity is going to decrease with order. As order increases, intensity is decreasing. So the intensity of central maxima is highest, first secondary maxima is lower than the central one, second secondary maxima having the intensity lower than first secondary maxima, and so on. Means intensity is goes on decreasing with order. Next, there is a good contrast between maxima and minima. Good contrast means the bright have highest brightness and the dark band have lowest intensity. Whenever the highest and lowest meet to each other, we can perfectly distinguish, or it can be noticeable. But whenever there is poor contrast between maxima and minima in case of diffraction, since the intensity of maxima is very small for higher order, so its intensity is too low, so we cannot distinguish the maxima and minima perfectly. Means there is no sharp boundary between maxima and minima, so it is called poor contrast. So there is a poor contrast between maxima and minima in case of diffraction pattern. So this is the difference between interference and diffraction, right? This is the question which so asked so many times in board examination, right? In a previous year CBSE question paper, there was a question to draw the intensity curve for interference and diffraction pattern, right? Sometime it asks what is the difference between interference pattern and diffraction pattern, right? So this is all about today's lecture. Thank you very much.